Welcome back, guys. In this video I will be exploring this question, and in this question here to the right we are giving two views of a figure. Two views. We're given a front elevation, we're given a front elevation, front elevation here, and a plan, and we're expected to draw the front, draw the two orthographic views, and also an auxiliary projection. I went ahead and draw this in 3D to help to clarify how this thing actually looks. And I would like us to analyze the question and also the solution in 3D to get a better understanding of how to interpret these questions. Currently I have two viewports. So let me change this to escape orbit. Alright, so let me zoom in into this and bring this around to that. Manipulate this a little bit to get it to be where I possibly want it. Okay, so this is the going straight into that. Get back here. This can be a little difficult to navigate at times, you know. Yes, it can be a little difficult to navigate at times. So this is pretty much the isometric representation of this. Yeah, the isometric representation of this. Now, on the front, let's analyze the front. So this piece right here, this piece here is represented by this section down here, and these two vertical lines here. These two vertical lines here are representative of this. They show the space here, and on the front, on the plan, this is what that looks like. Now, it is important to note that well, from observation, there are some little tips and tricks that you can tell to determine how an object shape basically. Now this line right here, this piece right here, this piece right here, this piece right here, if this pretty much says that an edge is created here, so right here. So what this line that extends from here says, from here to here, it tells that there's a sharp change in direction, or an edge is created. If an edge is created, we draw a line. If there's no edge, we let it stay straight, as is. Now here as well, this line here actually tells true that this is sloped, which is represented here on this. If this was straight, then we would not represent this. We have on a straight line going across, this piece would not be there. So these are tips that you can use to help to figure out the isometric view and also how these objects look. Looking from here, this piece here is represented by this view right here, and this piece is seen by viewing from this angle here. Yeah, and this piece here is the base that we see. Now let us rotate this to view it from the front. So yeah, from here I go up like that. That is basically the front plane. That's the front elevation right there. Front elevation. Front elevation. Parallel. Yeah, so this is basically how that would look from there. That's what I would look from there. We have this coming here. And if we were to go up top, left click here, rotate this a little bit. This is basically what we would see. This would be the end elevation, but for this drawing they did not ask for it, neither did they give us end elevation. If we were to rotate a little bit more, this would have been the auxiliary projection, the auxiliary view. Yeah, the view that we see when viewing from this angle across here. This is the auxiliary view. So we are seeing this face, which should have been here, as well as this face, which should have been here. We will also be seeing a part of this face, this edge, and also this face along here, which is this face here and along here, as well as a part of here, and also a piece of this right here. So this is the auxiliary view, and we would remember from previous class that the auxiliary projection is a two-dimensional representation of two views. Yes, two views. So here we have the front and the end combined to create this view. So that's the first auxiliary, and or the auxiliary projection. Now for the plan, if we were to rotate this figure a little bit more, we would get the plan. See the plan. So this section here represents this section here, and this here represents that. And the taper section, this line right here, this line here, pretty much give us a clue that this is sloped, and it is sloped downward. This line here gives us some clue that this is sloped. This is sloped, or there is an edge created here. Yeah, and based on the fact that it runs from here down here, which means that the slope runs from top down to bottom. Yeah, so it means that it runs from all the way up here, which is up here, down to the lower section down here. So these are things that you can use to be able to understand orthographic projection and represent them in a three-dimensional view. In most cases, these come in sketches. These come in sketches, sketch and design section. But just in case you're asked to do it otherwise. So this is another view of this. Yeah. Okay. So again, remember now, isometric projection is a three-dimensional representation of an object where the object is viewed from three angles. We have front, which can be here, or it can be here, front, plan, and end elevation. This would have been one end. The next end would have been that. And also the plan. The plan, which would be that. Yep. So that's all there is for this. I recommend that you watch watch my 3D solution to orthographic, isometric, and auxiliary drawing. I think these are some very useful videos, and they're even better for mechanical students because, as you're aware, for you to effectively master mechanical engineering drawing, you must master at least three topics. You must master orthographic projection, you must master sectioning, and you should know to interpret isometric drawing as well. So, mechanical engineering drawing is centered around knowing the sectioning rules, how to draw views how to change from isometric to orthographic, and how to change from orthographic to isometric. And to a good extent, if you understand, the better you understand auxiliary, the more the more likely you will be to figure out these questions correctly. Yeah. So again, guys, please like and subscribe.